Thanks a lot, Stefano, for inviting me to be here. I'm really deeply impressed by all the wonderful research that we have already seen today, and I hope we can make a little contribution with this presentation here as well. You see me actually, I'm greeting you from a hotel room in Lisbon, Portugal, which is why you have the nice theatric lighting here in the background. The title of the presentation, I'm going to give a simulation-based view analysis, and my co-presenters, or my co-authors, I should say, are John Sargent from Solema, Irma Turan, who did her PhD at MIT and is now an assistant professor at Illinois Institute of Technology, as well as current MIT doctoral student Nada Tarkan. We already heard a lot about the benefits of a view, and we heard just from Holly really nicely the different roles that different participants in the construction industry are playing. Obviously, we want to create a view in the end for the building occupants, but then there are architects that have their agenda, how they want to design buildings, and then there's, of course, the real estate sector. So just this afternoon, this tweet that you see here was sent out by Sideboard Labs, referring an article that reviews the work from Irma's PhD that I'm going to talk about briefly right now as well. And when you see at that picture, I think that shows that in a nutshell how the real estate sector is, here we go. How the real estate sector is thinking about view, which means the more the better, right? So basically, the moment we talk about view, we think of a full curtain wall facade, maximizing view anywhere in the building. And that's, of course, to a degree, the end of architecture. And Holly already alluded to the environmental problems that these type of facades have. So our, I guess, collective role is to educate the real estate sector that, of course, funds new construction and renovations to be convinced that our metrics will still lead to spaces that building occupants find attractive. So in the first part of my presentation, I'm just going to go about, if you want a model view today, how is that being done if you're a practitioner? And I'm using the framework that one here already used, content, accessibility, and clarity, to talk about these. So first, what have practitioners done for a long time when they wanted to evaluate view? They basically placed sensors coplanar with a facade and then shot rays out into the world, into their scene. And the scene can be manually created. And we just heard about this exciting method that Holly presents. But then you tag objects and you say screen, landscape, different things are desirable. And if you see this, you have a view. Probably one of the first really nice studies that did this was KPF Research, working with SUNY in New York, using the method that I just described to shoot out rays into the world and highlight certain landmark spaces within Manhattan. And then Luke Wilson has these beautiful visualizations where they show a whole skyscraper and how this warps, becomes this big mushroom effectively to maximize the number of apartments and spaces within this high-rise that have access to view. So that has been done for a long time. We heard from a couple of presenters as well, the LEED metric and the European daylighting metric, and the way these work. There are quite a few nuances, as I will discuss later in the presentation. But in essence, you are somewhere in a building now, not just positioned at the facade. You shoot rays out in the world. And in the case of view for LEED, you basically, when you shoot a ray out, as long as a ray through a vision glass hits an object that is more than 25 feet away from your building, then you have a view, no matter what you hit. If it's closer, then if you hit something that's tagged as nature, art, or urban landmarks, that counts as a view as well. And as we will see, there are some problems here. We actually call this kind of the bonsai approach, that when you have a building that's very next to a narrow urban canyon, if you just put a little bonsai tree, then LEED would already give you full credit for this. And then the second criteria is distance to the window glazing. If you are more than 3 times the vision glass height away from a facade, then this also doesn't count as a view. And so then taken together, type 2, type 3 that I just described, if you have a site-lit corner office here, an open plan office combined with a conference room, then you pretty much have everywhere access to view, except for in this little gray areas far away from a window or hidden by a column. And so the final component is now, of course, clarity. And so what could do there is going through time. And we have various algorithms already in place, even though we need a lot more work, predicting how people open and close their blinds or their smart glass system. And then if we, over the course of the whole year, combine this information with the view clarity index, then we have something probably very close to the view quality index that was just presented by one really beautiful work. So if we have all these three components, we can come up with this view metrics. As has been said by several presenters already, it kind of remains unclear whether these metrics correspond to occupant evaluations for a lot of spaces. And in order to come up with a view metric that links to at least some appreciation of view within a building, this is a collaboration. This is Imax Turan's research, a collaboration with the MIT Real Estate Innovation Lab, Andrea Shegut and Daniel Fink. And what we did there, teamed up with Andrea and with Daniel, to combine our design performance analysis tool with the financial analysis tools. And the way this worked, we 3 years ago first did a daylighting study of 5,100 floors in New York, where for all these floors, we had ComStack data, so detailed information about the real estate property and the rent value being paid. And then Irmak and Daniel developed this automated workflow that for each floor calculated the spatial daylight autonomy in the space. And this was put in a hedonic pricing model. So we basically look in how far property type, location, building age, number of floors, and daylight autonomy have an impact on explaining the rent. And in this first study, we found that having access to good spatial daylight autonomy across a floor, you get a rent premium of 5 to 6%. And now really important for the second extension of the study that was studied this year, we said, well, let's do an iterative view metric, where we came up with a framework that I'm going to explain in a second for a view, but then we tried different cutoff criteria to see which of these metrics would be the best predictor according to our data set for people paying higher rents. And so the first component here is Irmak's minimum view potential. So again, similar to what we've seen before, we're shooting rays out here, and objects of desire are iconic landmarks, distant views of water and the ground. We excluded view of the sky, actually, because we wanted to keep our view metric separate from the daylighting metric. So then the first question was, how much view do I have to have so that it counts as a view in terms of a solid angle or percentage of rays? That was one kind of fitting parameter. The second parameter was then how much, and I think this is really key, especially for our discussions with the real estate sector, how much of a floor plan needs to have a view? Because rather than thinking I have to have a view anywhere when I enter from the in the corridor, when I'm sitting in the bathroom, that is not necessarily the reality. People think about a floor having good view when a certain percentage of a floor has a good view. So two fitting parameters, how much do I have to see solid angle wise, and how much of a floor has to have good access to a view. Here you see, I'm not going to go into details here, but this graph summarizes our data for these 5,000 spaces for different cutoff angles for minimum view potential. And we found the best balance of having a discrimination between good and bad view for our data set was that you see 3% of your view, minimum view potential constitutes a view, and if more than 10% of your space have this view, then there would have good access to daylight. And when we put that fitted metric now into the same data set that I described below, we found still good access to daylight autonomy gives you a 6% rent premium. Good access to view only gives you a 6% rent premium. Now, unfortunately, maybe if you put them both together, you still get about a 6% premium. So these two are not additive. So now we have at least 3 different metrics. Would be good to repeat what I'm doing right now here with a larger group, with the other view metrics that were discussed today as well. So what do these view metrics reward? I think that's always a key question that you have to ask if you let a metric out into the wild for the design profession. So here I show the side lit corner that I talked about before. And what you see here, LEED basically says there's view everywhere. the European norm has this gradients of best view in the corner, and then this is falling off, which seems somewhat plausible. And similar, the minimum view potential, if I have the 3% rating, you also highlight the corners and place this very close to the window. However, this is work that Nada has just been working on. What is really interesting is when you start looking at a whole floor plan. So I'm showing here a big typical office floor plan, fully glazed with inset windows and with very deep inset windows with shading. So the lowest option is something that we had used as an example to optimize for glare, actually. And what you see, kind of view doesn't care. There's view everywhere in the surroundings. And once you have a parameter, once you have a core zone, even if the walls are glazed, view doesn't count them. The European norm has some gradients, and what is really interesting in our case, we have to see if that's intentional or not. The moment when you have facade that's outside of the view window, that already counts as an obstruction. So then you have, in this case, this kind of little funny effects where when you have a deep shading system with a skylight outside of your window glazing, this gets penalized, and it would be worthwhile knowing if that's in the purpose of the developers of the standard. And a minimum view potential for this kind of situation shows view everywhere. Now, if we are going to add outside urban objects, what we see basically, we first in the top one have the same result as before. There are no urban features. Once you start adding a piece of art very close to the window, less than 20 feet, further than 20 feet, and here we are adding art and trees, then you see, again, LEED doesn't react at all. Everything is the same, all is a view. In the European standard, there come these funny situations, and I think this is very much in line with the questions of nature or art and distance. When you have a close art object or a close tree, that actually gets penalized by the metric right now, which is maybe something here you see that might be worthwhile re-evaluating and discussing. For minimum view potential, what I find particularly interested is on the right-hand side, when you start looking at highlighting certain objects, such as art or nature, that I think the minimum view potential is really useful to help a designer use it as a design tool to say, okay, where within the buildings do I see the trees? Because I know this is, as we heard from William, this is really desirable. Where do I see art? How far does the art have to be? So I think these kind of tools that allow you to slice and dice certain components of the view are good for a designer to explain to them why the view gets a certain rating. And that would be probably my caution with some of the view metrics that were presented today. If we throw too many things together and combine them, then designers have a hard time understanding what they're actually looking at. So I think this cause and effect is always very hard to showcase that. So in conclusion, with this talk, I wanted to show that in terms of design computation, view compared to glare and daylight is very simple. We have basically everything in place to do real-time analysis of gigantic buildings. And with Holly's new tool, we can even create the surroundings really quickly. I think it's important to notice and to explore further. These existing metrics have very conflicting messages on what space is good penalized or not. And I think the minimum view potential is promising for design, but Mark and I, of course, clear all of us that it needs further validation, because just because people pay a higher rent doesn't mean that there is higher occupant satisfaction necessarily in a space. I think what I learned today is that we probably need, and the symposium adds to that, better information channels between the standard developers and software implementers, because we kind of spend a lot of time plowing through the standards trying to understand it, but sometimes I think maybe the larger intent of the standard should be discussed between developers and software implementers. And of course, as all my colleagues already said, we need coordinated human subject studies that basically validate all these one metrics that we come up with here. Thank you.